chemistry of tattooing, a journey through skin, ink, and identity. Tattooing, one of humanity's oldest art forms, is as much a chemical process as it is an act of personal expression, cultural identity, and philosophical exploration. From its ancient origins to its modern resurgence, tattooing has been interwoven with the very chemistry of our skin and body. Yet beneath the ink skin, tattooing is a world of paradoxes. It is personal, yet universally recognized, artistic, but deeply scientific. The question then is not just how tattoos work, but why we are so drawn to them. Tattoos have been around for thousands of years, long before the electric tattoo machine. Some of the earliest known tattoos were found on the mummified body of Otzi, the Iceman, who lived around 5,300 years ago. These tattoos were likely created with rudimentary tools, charcoal or ash used as pigment, and applied as part of a ritualistic or medicinal practice. The history of tattooing isn't just a history of art, it's a history of chemistry in action. Early tattoos used natural pigments derived from plants and minerals. Charcoal or soot provided the black ink, while other colors were derived from minerals such as ochre or iron oxide. Even in these ancient times, people intuitively understood the interaction between pigment and skin. Tattoo ink is a modern marvel of chemical engineering. The inks themselves are made up of pigments suspended in a carrier solution. These pigments are either organic, carbon-based, or inorganic, mineral-based, each with distinct properties that contribute to the longevity, vibrancy, and safety of the tattoo. The pigments are made from a variety of chemical compounds. For example, black ink is often derived from carbon or soot, while vibrant colors like reds, greens, and blues come from synthetic organic dyes or metal-based compounds. Red inks, for instance, frequently contain cadmium, while yellow may come from titanium-based pigments. Some pigments bond more effectively with the dermis, ensuring a longer-lasting tattoo, while others might break down or migrate more easily, causing the ink to fade or shift color over time. The pigments are carried in a solution that usually contains water, alcohol, and glycerin. The alcohol helps sterilize the ink, preventing infection, while glycerin keeps the ink fluid, allowing it to be easily injected into the skin. Water is the base solvent that ensures the ink flows smoothly. The chemistry of these carriers is essential to the safety and application of tattoos. If the solution is improperly formulated, it could cause skin irritation, poor pigment adhesion, or infection. Once the ink is deposited into the dermis, the body's immune system reacts. When tattoo needles puncture the skin, the body's defense mechanism kicks in, dispatching white blood cells called macrophages to remove what they perceive as foreign material. However, tattoo pigments are too large for these cells to fully digest, so the ink stays trapped in the dermis, giving the tattoo its permanence. This is where the science of tattooing becomes philosophical. The permanent nature of a tattoo forces us to confront the idea of memory and identity. Tattooing is, in essence, an intentional scar. It is a mark we choose to carry forever, a chemical artifact embedded in our bodies that represents a personal narrative. This permanence raises questions. What does it mean to mark the body in this way? Why do we choose certain moments in time to immortalize on our skin? And how do we reconcile the constant change of our inner selves with the unchanging nature of the inked image? At the same time, the body's reaction to ink represents an intimate connection between human biology and chemistry. The pigment becomes embedded in our skin, a fusion of the synthetic and the organic. Our immune systems fight against it, yet it remains. In this sense, a tattoo can be seen as a dialogue between the human body and the chemicals that form the ink, a conversation between science and art. Despite the beauty and cultural significance of tattoos, there is an inherent risk in the chemicals used to create them. Some pigments, especially those containing heavy metals like cadmium, mercury, or lead, can pose long-term health risks. These metals, when introduced into the body, may accumulate in tissues and potentially cause toxicity, organ damage, or other health complications. Some individuals may experience allergic reactions to certain pigments, particularly the red inks, which often contain potentially irritating compounds. The immune system, in its attempt to defend the body, may trigger inflammation or form granulomas, small benign tumors around foreign substances. In the worst cases, tattoos can lead to chronic skin conditions or even scarring. Thus, the interplay between body chemistry and tattoo ink is a reminder that science is never completely separated from art. It's always intertwined with risk and consequence. At a deeper level, tattoos are often viewed as a rebellion against the fleeting nature of life. In a world where much of our existence is transient, tattoos represent a way of carving out a piece of permanence. The ink becomes part of us, physically, but also emotionally and psychologically. It's a form of storytelling. Each tattoo holds a fragment of who we are at a particular moment in time. Tattoos are not merely decorative, they are transformative. In the end, tattooing is a profound example of the intersection between science and art. The chemical processes that create a tattoo are as intricate and fascinating as the cultural and personal meanings we imbue into them. The art of tattooing, whether it's an expression of personal identity, an artistic statement, or a nod to history, reminds us that the body is not just a vessel, but a living canvas, shaped by the chemistry.